Hello, everybody. Thank you for coming to this session. My name's Rick Harvey. Currently, I'm a technical evangelist at AWS. However, I've got a slash in there because next week I'm moving into the Startup Solutions Architecture team. You're not going to get rid of me that easy, though. I'll still be on stage everywhere giving talks like this. So I've put my contact details on here as well. So if you've got any questions from the session today, you can feel free to email me or drop me a DM on Twitter or publicly abuse me on Twitter, whichever you prefer to do. And I've always got sample code for some of the demos we do over in GitLab. I'm going to talk to you today about IAM, Identity Access Management, and why it's really, really important. Now, there's one theme you're going to hear me say quite a lot through this talk is never ever commit your IAM credentials to anything like GitHub, GitLab, Bitbucket, any version of source control. And that's the end of my talk. No, it's not really. I'm going to say it a lot, though, as we go through. So I'm going to talk to you about IAM, what it is, why it's important. And we've got quite a large range of security propositions on AWS. We've got ways of looking at incident reports, so we can have config rules. We've got the data protection. Amazon Macy, for example, is a machine learning way of looking at data you may store in your S3 bucket and deciding whether it's got sensitive data on it. If it has, it'll automatically lock down the access to that data so you don't have any data leaks there. We've got Amazon Inspector, which looks at your AWS EC2 instances. You can either have the client on board or you can remote scan them, and it'll do an audit for you. We then go back through things like CloudTrail, which is an auditing tool, which I'll mention in a little bit as well, that shows who's done what, using what tool, at what time, to what service on AWS. And then we've got the identity side. The one we're going to talk about today is right at the top, Identity Access Management, and it actually underpins everything else on this slide. IAM is one of the key components of AWS. IAM lets you control who can do what within your account and what machines can do what within your account. And we'll talk about that as we go on. So I'm going to start off, though, with a little bit of basics here. So sorry if I'm teaching to suck eggs, but let's have a look here. I'm going to talk about something called least privileged and shared responsibility. Two concepts that I'm going to mention quite a few times throughout this, as well as not committing your keys to any kind of source control. So, shared responsibility at AWS. This is a way of letting you know which bits of the infrastructure that's being spun up by yourselves you have to maintain and look after. And it kind of changes between which service you're using. If we look at this, this is the base one. We look after the security of the cloud. So we look after all the infrastructure, the physical buildings and the access to it, the hardware that runs the virtual machines that you're going to run the EC2 instances. We look after all of that. Networking, we look after that as well. However, on your side of the responsibility model, this is the stuff you run in the cloud. So when you create an EC2 instance, you need to control that with things like security groups for access. But also, who can spin up those EC2 instances? That's where IAM comes in. IAM allows you to do things within your account. And IAM being one of the key bits on here, at platform applications and identity and access management. The other thing I'm going to talk about is least privileged. If somebody doesn't need access to something, if they've never tried using a service, don't give them access to it. Let them request it. Let them hit a blocker and then say, please can I have access to create an RDS database? Please can I have access to delete data from DynamoDB? Until they need that, don't give the permission. And that doesn't just go for human beings sat there typing away at the keyboard. That goes for your programs that you write as well that may use IAM roles. Don't give the permission unless you need it. This kind of minimizes your blast radius. If those keys get exploited, if the instance, that EC2 instance gets exploited, you can limit the damage that's done. And it's very, very granular, as you'll see as we go through. So the quote of the day, if you don't need the access, don't grant it. I thought that was quite catchy. I might have a t-shirt made up with that on. So, AAA at AWS. We've got the Authenticate, which is a bit about is your username and password correct, or in the case of programmatic access, are your security key and your identity key correct? And if you have MFA, multi-factor authentication enabled, has that worked? We've also got federation. We can actually control IAM users through Active Directory that may be on-prem for you. And using SAML, you can link it together, and you can create groups within your Active Directory who then get access granted to AWS resources, depending on how you've mapped the groups. Authorize. This is, okay, you've logged in, but what can you do? And this is where IAM policy comes into play. An IAM policy is the bit that says, you shall not delete things from S3, or you shall not create EC2 instances to go and Bitcoin mine. All these kind of things. You've got the control to do in a policy. And then we've got the audit side of all of this, which is CloudTrail. CloudTrail logs every call against the API and console into logs that you can pull down and get. And it's a bit of a bigger conversation than this, but best practices say that CloudTrail logs, you should export them to a separate AWS account and have them locked away. That way, if somebody has exploited your main working account, they can't tamper with the logs. It means you can go back and you've got forensics to look through and work out how and why and how you can prevent it in the future. So that's the basics out of the way. Let's start talking about what we're here for, identity and access management. So when you first set up an AWS account, you use an email address, you stick your credit card in, you either get a text message or a telephone call to verify you're a real person and not a spam bot. And the access you get with that login is called the root login. And that root account can do anything. It can delete users, create users, it can spin up any type of instances, it can request extra access to services you might not have enabled. And it's also got access to the billing API, so you can look at all the billing data. You then have this hierarchy. The next level is IAM users, and these are users you add individually. And you add these in the console, and these are the ones that should be used day to day. The root account, if you can avoid it, and you really, really should try hard to do this, should be locked away in a safe somewhere, and you don't use it unless you absolutely need to. So IAM has users, groups, and roles. A group's kind of self-explanatory, isn't it? It's a group of users. So all of us on the front row might be the admins. All of you on the front row here might be Dev Team 1, and you at the back might be Dev Team 2. We should have access to everything in the AWS account. You should only have access to one particular app, and maybe that app runs in Lambda, so we'll give you Lambda access. And the devs at the back need EC2, they need S3, they need RDS, they need DynamoDB. They built this brilliantly wonderful, fantastic app with every resource in AWS in it whatsoever. They need a lot of access. So we can naturally split that down. We can give you less access than they need, and we've got all the access that we need in that account. And we can delete you if we need to, and add things to your account if we need to. And then there's something called temporary security credentials. I'm not going to dive too deep into that today. This is a way of having your application request keys that are only valid for a set amount of time. And it's a way of doing things with applications that may not run within AWS. It may run on on-prem hardware, and you don't want to store keys there all the time. So you can make a call, request some temporary keys, do the work for the time you need to, and then the keys expire. And this is kind of how roles work as well. So roles are what you give to machines. Users are humans, roles are for machines. Lambda functions, EC2 instances, RDS, all these services you can apply roles to. And what you can say is that my application, let's say I've written it in PHP, I'm running it on this EC2 instance, and I want that to be able to put items in an S3 bucket. So a user comes along, they upload an image into my PHP app. My PHP app then uploads that into S3. Now that means my EC2 instance is going to need access to write to S3. So that's the access I give it. And I get granular. I say it can write to S3 only in a bucket if it's called this name. And then that way I don't have any leak where if somebody's exploited the app, they could start deleting or they could start writing data into other buckets. So, authorization and privileges. Like I said before, the root account. Please try to do this if you can. Enable multi-factor authentication on it. You can either do it with a phone app. I've not got my phone in my pocket because obviously I'm doing a talk and that'd be a bad idea. You can either do it with a phone app like Google Authenticator or the YubiKey Authenticator. You can actually use physical devices. So these two here, quite hard to see at the back, I appreciate. These two here are YubiKeys, and you plug them in, and once you've logged in with your username and password in the console, you have to tap the key, and then it sends a one-time password to the console and allows you to log in. The other way of doing it is with one of these, which is more like the RSA tokens that we've all used in big corporations. This is called a Gemalto key, and when you come to log in, it'll ask you for a code. You press the button, and it generates a code for you that you then type in on the console, and it allows you to come in. What I'd recommend with the root account is enable one of these, and then lock it away in the safe with a password, and never use it again unless you really, really have to. The next level then is IAM policies, which I've talked about, and this is the way that we're going to use to grant. And I'm going to give you a little demo of how to do this in a moment as well. So let's just recap a little bit. Identity access management, it allows you to define users, groups, and roles. It protects your AWS credentials, and you can get very fine-grained with it. By that, I mean you can give very specific actions to users. You could, I like using S3 as an example, and that's going to be my demo. You could say only have read access to a bucket. So they can read objects out of that one bucket, but they can't do anything else. You could say you are allowed to delete from that S3 bucket, but in order to delete, you've got to go and enter your multi-factor authentication code. And then that stops the accidental deletion, which is a really good thing to do if it's important data to your business. So consider using things like that to do the fine-grained access. So users, groups, services, and roles. Roles we've touched, groups and users we have. Services, kind of the same thing with roles. What we're doing, we're defining what the roles can actually do within our account. And this becomes quite important when we're using things like EKS. So there's some service roles with EKS, which are IAM policies that you don't have to define. We define them for you, and it allows us to do things like start an Elastic Network interface within your virtual private cloud in order to connect in the control plane of Kubernetes, for example. So there's service roles as well. And the wonderful upside-down pyramid, I just had to include this because it's very colourful and I like it. The person with the most power on an account is the account owner and the root user. Because it's the most powerful, that's why you lock it away. One of the other things you can do on this as well is you can actually disable any programmatic access from the root account. You can delete the keys. And that's probably a good thing to do as well when you're first setting this up. Another thing I'd say is when you first set your account up, I always recommend that you go in and have a look at some of the pages around the support and billing and add your contact details, such as go in there and add a technical contact, a security contact, and a billing contact, and have different emails to the main root account. Why is this important? Well, I've seen a few times where somebody in the business, they've set up the main account, they've left the business, their email address has been shut down, somebody goes to log in, they forgot the password, they try and do a password recovery, the email doesn't exist, there's a big flap in the office, somebody tries to put the email back on, discovers we can't find the password anyway, so you ring support up. And support will say, okay, we need to confirm you are you, so we're going to email you. And the whole problem starts again. But if you've defined things like billing contacts, technical, and security, you can use those other email addresses. And I'd set them up as like alias groups in your email. So have AWS security at mycompany.com. And that can be assigned to any user within your organization. The next powerful set of users are us, the humans, the developers. We can go in and we can use IAM and we can create things. We can run CloudFormation templates, we can create EC2 instances, workspaces, whatever we want, as long as we've got the permission. And then we've got temporary security credentials, STS. And these are the things that roles use. So the temporary credentials that allows an instance to do something for a set amount of time. So because they expire, there's less exposure on that. So, protecting your credentials. Like I said, least privilege is the most important one. It's so tempting to give everybody admin user when you first set up an account. Especially if you're a startup and a small team, it's very tempting. Try and avoid it if you can. You'll have a much nicer time. You won't ever get into one of those situations where you've grown a bit as a business. You've then got to do an audit, so you decide to start locking things down. And then things start working because somebody's hard-coded the keys in some code somewhere and tried to do things. Enable multi-factor authentication on the root account and the user's accounts. All users can have a multi-factor authentication device. So this is just an extra bit of security for you. And we've got these password policies as well, which you can see at the top here. Password policies let you set the minimum length, whether you've got special characters in there, how often they expire. These are all sensible things to do. So really, just spend the time. It's 5 minutes at the beginning. Do that, and you'll have a nice way of moving forward. And then avoid storing API keys in source control. So I've mentioned roles, and I like roles because they give permission to my code to do things. Now, way back, and we're talking over 10 years back when I first started, when you wrote code, you used to create a set of API keys. You used to embed it in your Python somewhere, and when you run your Python script, it would go and use these keys and connect in. It's not the way to do things. The way to do things is embed no keys in your code. That way, you can't put any keys into source control, and your account can't get exploited. These are good things. So, IAM roles. What happens? When my Python script runs in, let's say Lambda this time, my Lambda is executed, and it says, create a table in DynamoDB. What happens is that Lambda function makes a call to the STS, the simple token service, the short-lived credentials, and says, do I have permission to do this? If the answer is yes, that function is returned a set of temporary keys, and it can execute and it can create that table in DynamoDB. If the answer is no, you don't have permission to do this, it won't get any keys, and it can't do it. Now, the nice thing about that is nowhere in the code that I've written have I embedded any keys. And that's good because I can't leak those keys by accident. And if I leave the company and my account gets shut down, any keys associated with my account also become inactive. So all of a sudden, that Python function might stop functioning just because I've left the company. And then everybody scrabbles around to try and work out why that's gone wrong. So, least privilege. This is my favorite slide because this is the worst least privilege slide you'll ever see in your life. So this is what an IAM policy looks like. And on here, we've got, oh, hello. If my pointer works, I think the battery's going, never mind. On here, we've got a policy. And on this policy, we've got a version and a statement. What I'm saying here is allow any action, that's a star, on S3 to any resource, so any S3 bucket. So this is the worst example of least privileged ever. What you should be doing is locking this down, and we're going to have a look at this in the demo as we go along. What we should be saying is this bit of code or this person needs access to 1, 2, 3, 4 buckets, and they only need write access, or they only need read access. I don't want to allow them to delete. I don't want to allow them to archive. I want to just lock them down to the bare minimum. Aircraft taking off. So what you should have is something a little bit more like this. And on here, we've got set up our user or our code, first of all, can list the S3 buckets. This is one that I've missed out several times. If you get to do the list, lots of programs and lots of libraries out there stop working because they want to list all the buckets before they jump inside a bucket to read the objects. And then from that, within the bucket called example bucket, I'm allowing you to do anything in there. Well, I'm allowing you to tag, to list, and put objects. You can't delete. And then the last bit at the end is a bit that lets me list all the S3 buckets. And you'll see this in action in a second. So our IAM users. Our IAM users can be developers. We gave that example. Admins. But also there could be billing. Your accounts department might want access to go and download the PDFs of the bills or the CSVs. And you can create an IAM user for them and give them access to billing. One thing to note is when you set this up, you have to use your root account to enable API programmatic access to billing first. So remember to do that. And you can now use IAM to control access into things like your RDS database. So you can use the same keys that you use elsewhere to actually log into a MySQL compliant database. And I think there's a talk on it over there before this session. So it's quite a good thing to look at. And it just simplifies how many sets of credentials you've got to manage, you've got to keep. I mentioned these MFA tokens. Highly recommend switching those on. They're relatively cheap. The YubiKeys are probably the more expensive way to go, but there's no battery in them. And that's a nice bit. So if you're locking it away in a safe and you go back to it 8 years later, you've not got to worry that the battery's gone and you can't log in, which is handy. And this blog here, which was written by this handsome chap in the corner, this is about how to enable YubiKeys on your account. And it's a pretty cool way of logging in. So I'll let you take a picture of that and get me some hits on my blog. So, users, groups, centralized access. A little bit of a visualization here, so when you've got the slides, you can see that we can have different groups of users with different sets of access, just to bring that home. Now let's go into the demo. This is just a bit more fun now. So I'm going to drop in here. And first of all, I'm going to take you into the IAM console. I'll try and make this a bit bigger, as big as I can for you to see. So I'm going to go into the IAM console. And I've already preset some things up here. I've created myself a user. Please ignore the big orange warnings about some of my accounts. It's a test account. So I've got a user called S3 Demo. And I'm in a group called S3 Demo as well. So my user's in a group. So if you came along and wanted to be part of my organization, I could add you into this group and you'd have the same access as me. It's a lot easier than doing it user by user by user because you end up repeating or missing things. So groups are very important. At the moment, this group has no permissions. It has least privilege, none. So what would that look like? If I'm going to drop to my shell here and make this as big as possible, I'm going to try here. I'm going to do an AWS S3 list. So I'm going to try and list all my S3 buckets that I have in my account. I can't. I get an access denied. And that's because this user's keys is part of that group which has no access. So the thing to do there is to drop back to IAM and let's attach a policy. Now a policy is a bit that's defined that says what we can do. So I've pre-created, it's a bit like a Blue Peter demo this, I've pre-created some policies here and we'll have a look at them. I'm going to attach this policy and then I'm just going to show you to have a look in. This policy is pretty basic. It lets me list all my buckets and the objects within, but that's it. And you'll see how useless this policy actually is on its own in a second. So now, Sometimes it takes a little bit of time to propagate these policies as well when you attach them to a group, so that's why I'm kind of ad-libbing in between these attaching policies. If I do an AWS S3 list now, yay, I get back a big list of all my S3 buckets. And I've got quite a few because I've got a few different demos floating about. But I can list them now. And I can go even further than that. If we take this one, for example, and I say AWS S3 list, and we look inside RIC transfer. Ooh, where are we? RIC transfer AWS, I think. That one. Let's have a look inside this bucket. I can go in and I can list objects inside. You can see I've got something called archive.zip and meetup mapper. I've got a video in there. I've got some PowerPoint presentations in there as well. You can see we've got access. So I'll go, oh, okay. I might want to grab the. I might want to go and grab this particular PowerPoint presentation to download. So what I do, I try and do an AWS S3 copy. S3, RIC transfer, no, and give it the name, and say I want to download it to this directory here. So I'm going to try and run that now. Oh, forbidden. Now that's because my policy only allows me to read what's in the bucket. It doesn't actually allow me to download the objects. It doesn't allow me to do a get command to pull that data down. All I can do is simply list what's in there. So this is the difference between list and get. List lets me see the file names. Get lets me get the data and download that. So in order to fix that, we drop back to the console. I'm going to detach this policy. And we're going to go in here and we're going to go for S3, number 2. I'm going to attach this policy. Now this one's slightly bigger. I've got a lot more things going on in here. In fact, this policy can actually do quite a few things. This lets me get things status like the cause status of the bucket and some bits and pieces to do with managing the bucket as well. But the key thing in there, and you can see at the bottom, is we've got, near the bottom anyway, we've got S3 get object version, but we've also got S3 get object a little bit higher up, the shorter one above the word torrent. So I can get the object. That means I can download it. So if we try our command that we just failed with, and down here, this part of the policy is my bit I had before, which is list, and get the details of what's in there. So let's move this up the screen a bit. Let's try this command once again, and we're going to ask this to pull it down. Hey, it's downloading. So I've now downloaded that file. I've given myself the access I needed. I added it as I needed it. So I've been working quite happy. I've been downloading things, and now I've decided it's time for me to contribute back and upload something. So if we have a look in here, we're going to do a, excuse me, we're going to do an AWS S3, and we're going to copy a file from local this time. So I think I've got a, yeah, I've got a YAML file here that I'm going to try and copy up. So my file's called Fargate Cluster YAML. I'm going to put that in my RIC transfer AWS, and let's call it test.yaml. So I'm going to try and upload this file. And if I try this now with this policy, access denied again. So yet again, least privilege kicking in, stopping me doing something that I potentially shouldn't. And if I accidentally put my AWS keys up on the screen here, you couldn't do anything with it either, because you'd only have the same permission as me. So you couldn't upload a load of stuff to my bucket and give me a big bill. Not that I pay my AWS bill. Thank you, Uncle Jeff, if you're here. Run lots of things. So detach this policy. And once again, I'm going to attach my next version. And my next version, I'm going to point out something on this. So pretty much the same. We've got all the get commands, but you'll notice now we've also got a set of put commands. So this is going to allow me to upload things. So this is how I'm showing you the fine, granular access control. I could just pick and choose 2 or 3 of these if I wanted. I could really narrow down this and only allow certain operations. So you can get really quite prescriptive with your IAM policies. Now, here I've got this section here called resource. And on here, I'm saying that you can only do things in a bucket called RIC transfer AWS. So all these things listed above, I can only do on one bucket. And then down here, if I want to get my information about what buckets I have and what objects are in there, I can do that on a resource, which is any. So I can look at any bucket. If I wanted to lock that down, I could actually say you can only look at a bucket if it's called this. And then I can really start limiting. So you could stop people even seeing other S3 buckets. You can get really, really granular, and it's really wise to do so. So now, if I try to copy my file up, there we go. We've uploaded that very quickly because it's quite small. But that uploaded, and now if we do an AWS S3 LS and RIC transfer AWS, within, oh, I've locked myself out somehow. Ah, I know what I've done. I've changed the policy this morning. Anyway, if I put the first policy back on, that'd list it and you'd be able to see it in the bucket. But I've managed to remove the actual listing everything in that bucket command to myself because I put a star on the end of my policy earlier. So what I'd do to fix that, let's try and fix it live. Because what could go wrong with that? So we're going to edit this policy. And I'm going to go into the JSON view because I like living life on the edge. And what we'll do here, we'll put a comma after this. And then I'm literally just going to copy this line. And then drop that in. But I'm going to remove the /star. View policy. Save. So let's allow that to take effect a moment. This is what I say about propagation. It sometimes takes some time, so I don't know if I've actually fixed it or not, but we shall see in a second. Talk among yourselves while this propagates. We'll test that in a bit. Anyway, I've given myself least privilege, so I can't do that. But one of the other nice things about that policy was it's limited to a bucket. So you could see I could upload and I could download a file with that policy. So if we do AWS S3 LS and we go and have a look at my slides bucket, for example. S3 LS. You'll see I can list things in that bucket now. But if I try and copy a file from here, and he says this without having tested it, we'll go here and we'll mention this PowerPoint, and we'll try and download it. We should get an access denied and a forbidden. Now if we drop back to our other one, I think that's to do with the order I've got things in. I'll post on Twitter how to fix that a bit later. So that's how you kind of lock down your account. You can minimize the access to what users can do, and you can really lock that down and make it pretty secure. And that means that if you've got employees in there and you don't want them to have access to, say, the financial records or the HR records that you're storing in AWS, you can make sure they don't have access to that data. And you can apply these same rules and this same granularity to things like databases. You can stop users creating security groups that would let them do things. A useful one would be to stop users doing creating EC2 instances with GPUs on them, so they can't go and use your money to go and Bitcoin mine very, very inefficiently and try and get some cryptocurrency for themselves. And also hackers. If you've locked that down and the keys that get exploited and someone gets into your account, they can't do that thing. If you've let your root credentials go out, that's where you've got a little bit of a problem. Because, like I said, root credentials can do anything. And that's why you never commit them to source control. Remember that? I'm going to test you all at the end. So doing things like that just limits what damage can be done. Now, I mentioned source control quite a lot. And that's because now you'll get this nice email address if we detect you've accidentally pushed them to GitHub. We actively scan GitHub, And if we see your keys going to GitHub, we'll send you an email pretty quickly and say, we've noticed your keys have been committed to a public repository. You may want to disable them. And we can even take action on your behalf for that. And that's because we found that if you accidentally commit your keys to GitHub, it's less than 30 seconds before somebody has found those keys and done something naughty in your account. And one of my colleagues, Mike McKay, he's got a very, very good talk on, I think he calls it 3 hours of pain. We actually tried it. We committed some keys to GitHub on a Scratch account to see what would happen. And it was one heck of a mess to clear up. So really do not do it. And it's not just in your local region. They'll do it they'll spin stuff up in every region around the world. So they'll max out every type of instance in every region. So you're facing a big bill. But if you get exploited, do contact your account manager, is all I can say. They'll look after you. Right, if we drop back to the slides now, and we'll just wrap up here. So IAM roles. What I showed you there was an example of IAM user and a policy. IAM roles aren't that much different. All it is to say this Lambda function, this EC2, the code running on it can do these things. So my example of just S3 was a pretty basic example, but that's probably sort of a policy you want to apply to a role to say you can do these actions. And one of the things you can do, this is one of my roles, which is very, very similar to the S3. So this is for a particular piece of Lambda code that picks up logs. I can't remember where it picked the logs up from. It picked up CloudFront logs from S3, converted them into Elasticsearch format, and then pushed it to Elasticsearch. Now, the problem with this is it says Elasticsearch star. It can do anything. It can delete indexes in Elasticsearch. It can create new Elasticsearch instances. But then I locked it down a little bit, and I said that the resource it can use is a Elasticsearch instance called domain logs. So I've limited its scope a little bit, but if I was doing this properly, I'd go in and I'd lock that action ES star down to just being able to push logs and the basics that it needs. So it's a very, very similar thing. It's the same principles as a user. Always apply least privilege and get granular. That's the best thing to do. Only grant the little bits you need. And when you look at the documentation, you might be hitting the face with a wall of options. It's quite quick to go down there. And if we drop back to Firefox a second, there's actually a AWS IAM Policy Generator tool. Here we go. I've used this site before, as you can see. There's a little policy generator tool here. And you can go in here and you can say, I want to generate an IAM policy, and I want to allow access to pick the service. And you can then go through and select what actions you want to give access to. So if we just say get bucket location, get bucket locations, and we're going to be naughty and say star, it'll actually go and generate an entire policy for me to copy and paste and create my policy in the AWS console. So it's a really, really useful tool. And it's AWS Policy Gen.s3.amazonaws.com. I'll send you the link later. But it's a really cool tool to do things like that. So some other resources if you want to do some deeper reading. If you want to see the ins and outs of STS and the simple token service, the documentation's there. AWS IAM, which is of course what we're talking about. And then we've got AWS organizations. So if you've got more than one account, this is kind of rolled into other products now as we go along. But this is a way of managing multiple accounts and having standardized sets of policies for your users across different accounts. One of the other things you can do with IAM as well is you can actually assume a role in another account. So if you've logged into your main account and you have the STS assume role privilege, you might have logged into your production account, but you've assumed a role over in the dev account, for example. So you can access things in another account and assume roles. So that was a very quick deep dive into to AWS IAM. I'll be about to take some questions after this. And like I say, you can always drop me an email. I'm rjh@amazon.com, or ping me on Twitter. That is a double underscore there. There's a story behind the double underscore, which if you see me for a beer later, I'll tell you. And please do get in touch. Ask me questions. If I can't answer, I'll put you in touch with one of the IAM team, and we'll talk then. But thank you very much.